Alright, this is section 5.6, part 2. We're trying to find the vertical asymptote of this function. So what I'm going to do is I'm going to factor the top and the bottom. So this will be x squared minus 5 squared. So we'll have x minus 5, x plus 5. And then looks like I can factor out an x on the bottom. Had an x squared minus 6x plus 5. And now I'm going to try to factor that as well. So x minus 5, x plus 5. So it'll be x looks like I can use a 5 and a 1, both negative. Negative 5 times negative 1 will give me positive 5. Negative 5 plus a negative 1 will give me negative 6, so that checks out. Okay, I can factor out this right here. So keep that in mind. So x minus 5, x plus 5, set it equal to the thing we don't want it to be. So x cannot be 0. X minus 5 cannot be 0. X plus 5 cannot be 0. So x cannot be 5. X cannot be negative 5. Okay, so our vertical asymptote is, no, that's right. I made a mistake right here. This should be negative 1. I don't know how to change it to a negative 5 there. So that will be 1. Okay, so x is equal to 1 is our vertical asymptote because I cannot factor that out, or not factor it out. I cannot cancel it out. And we will have a hole at x is equal to 5. And also, we will also have a vertical asymptote at x equals 0. Couldn't cancel out the x equals 0 as well. Okay, these are the two things that I couldn't cancel out. Now let's talk about identifying horizontal asymptotes of rational functions. So a horizontal asymptote of a rational function can be determined by looking at the degrees of the numerator and denominator. So we'll have three cases. If the degree of the numerator is less than the degree of the denominator, then what we're going to have is a horizontal asymptote at y equals 0. If we have the degree of the numerator is greater than the degree of the denominator by 1, then we have no horizontal asymptote. What we actually have is something called a slant asymptote. And then last one, if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote is the ratio of the leading coefficients. So those are the three possibilities that we will look at. So what I'm going to do is find the asymptote, and I'm going to look at the degree of the numerator and the degree of the denominator. So the degree of the numerator is 3. The degree of the denominator is also 3. So since they are equal to each other, that means that the horizontal asymptote, back over here is the last one, they're equal to each other. So it'll be the ratio of the leading coefficients. So that means that y is equal to the leading coefficient. For this one is 6. The leading coefficient for the denominator is 2. So it'll be 6 over 2, or 3. Okay, so our horizontal asymptote is y is equal to 3. Okay, now looking at this one, let's find the degree of the numerator, which is 2. Degree of the denominator is 3. So the degree of the numerator is smaller than the degree of the denominator. So coming back here, degree of the numerator is less than the degree of the denominator. So we're going to have an asymptote at y is equal to 0. So y is equal to 0 is our horizontal asymptote. Okay, now let's look at this one right here. Okay, the degree of the numerator is 2. degree of the denominator is 1. So here the degree of the numerator is bigger than the degree of the denominator. So that's this middle case right here. So we've got the degree of the numerator is greater than the degree of the denominator. So there's no horizontal asymptote. What we have is a slant asymptote. So horizontal asymptote, none. Or you can say, hey, there's a slant asymptote. Okay, and the way you find a slant asymptote is by two ways. You can either use long division or you can use synthetic division where possible. Here, we can use synthetic division. So we're going to take this right here and we're going to have 1, -4, and 1. And notice that it goes 2, 1, and 0, so it's in descending order. Bring that 1 down, multiply those two. So -2 times 1 is -2. Gives us -6. -2 times -6 gives us positive 12, and so that's 13. So notice how this up here started at x squared, this was x, and this was our constant. For our answer, remember we're going to start at one below, that's going to be x, this is going to be our constant, and this is our remainder. We don't worry about the remainder. So our answer is x minus 6. Okay, so this would be our slant asymptote for this particular question. And then let's look at this one. This one's factored, so we're going to have to figure out the degree of the numerator. So this is x raised to 1, this is x raised to 1. So x times x, that will give me x squared, so the degree here is 2. X raised to 1, x raised to 1, x raised to 1, so x times x times x is x cubed, so this is 3. So the degree of the numerator is less than the degree of the denominator. So that has got to be this one right here. The degree of the numerator is less than the degree of the denominator. So our horizontal asymptote is y is equal to 0. So horizontal asymptote, y is equal to 0. And that's it for that one. And actually they also ask us what is the vertical asymptote. So let's get rid of this right here. That was for our horizontal. And let's find our vertical asymptote. So remember that's, we set the bottom equal to 0. And first I'm going to make sure that nothing cancels out. That's a positive 2, that's a negative 2, and I don't see a plus 3. So nothing cancels out, which means we don't have any holes. So I'm going to take x minus 1, x plus 2, x minus 5, set it equal or not equal to the thing we don't want to be equal to. Set it not equal to 0. So x minus 1 is not equal to 0. X plus 2 is not equal to 0. X minus 5 is not equal to 0. So x equals positive 1. X equals negative 2. X equals a positive 5. So all of those are vertical asymptotes. So we've got x is equal to 1, x is equal to negative 2, and x is equal to 5. So all of these would be our vertical asymptotes. Now let's look at the intercepts of rational functions. So a rational function will have a y-intercept at f of 0. So basically that's saying that you're plugging in x equals 0. If the function is defined at 0. A rational function will not have a y-intercept if the function is not defined at 0. Likewise, a rational function will have x-intercepts at the inputs that cause the outputs to be 0. So basically we're going to plug in y equals 0 here. Since a fraction, this is the important part, since a fraction is only equal to 0 when the numerator is 0, x-intercepts can only occur when the numerator of the rational function is set equal to 0. And I'll show you what to do there. So we're going to find the intercepts of this function. First, let's go ahead and find the y-intercept, which means x is equal to 0. So f of 0 is 0 plus 5 over 0 squared plus 4. So that's 5 over 4. So there's our y-intercept. And then our x-intercept is where y is equal to 0. So we're going to set this equal to 0, x plus 5 over x squared plus 4. Now, I've said before that 0 over a number is equal to 0, whereas a number over 0 is undefined. So we're looking at this right here. It does not matter what that number is. It only matters that the top part is 0. That's what makes the entire thing 0. So we really don't care about this number right here. So what we're going to do is we're going to take the x plus 5 and set that equal to 0 and solve for x. So that's going to give us our x-intercept. So our x-intercept is -5. So if we were going to write this in ordered pairs, we would have for this one, it would be 0, 5 over 4. And then for this one, it would be -5, 0. Okay, now let's look at this one right here. So I'm going to go ahead and find the y-intercepts. So f of 0 is equal to 0 squared plus 8 times 0 plus 7 over 0 squared plus 11 times 0 plus 30. So that will give us 7 over 30. So that will be 0, 7 over 30 for our y-intercept. And then for our x-intercept, we're going to have 0 is equal to x squared plus 8x plus 7 over x squared plus 11x plus 30. Now remember, in a fraction, the only part that's going to make the 0 is the numerator, so don't care about this. So 0 is equal to x squared plus 8x plus 7. Now we're going to factor that if we can. Looks like I can take a 7 and a 1, make them both positive. 1 times 1, 7. 1 times 7 is 7. 1 plus 7 is 8. That works out. So let's come over here. X plus 1 equals 0. X plus 7 equals 0. So x equals -1 and x equals -7. So as an ordered pair, that would be -1, 0, and -7, 0 for my x-intercepts. Okay, let's look at this one. Y-intercept, and that's going to be 94 minus 2 times 0 squared over 3 times 0 squared minus 12. So that's going to be 94 divided by a -12. Now I can take a 2 out of both of these, and I'm left with -47 over 6. So that would be 0, -47 over 6 for my y-intercept. Okay, now let's find our x-intercept. Okay, so 0 is equal to 94 minus 2x squared over 3x squared minus 12. Again, I don't care about this right here. I just care about the numerator being set to 0. Okay, so I'm going to move 2x squared over, divide by 2. So it looks like, I'm going to come over here, x squared is equal to 47. And then we're going to square root, put your plus or minus. So x is equal to plus or minus the square root of 47. So that means our x-intercepts will be square root of 47, 0, and negative square root of 47, 0.